Magnetism is nothing but a phenomenon of attraction. So the phenomenon of attraction of particles like iron, nickel, cobalt. These are the types of magnets. Let us know some of the common properties of magnets. What are the properties these magnet experiences? Where the magnetic fields are close together, the magnetic field is strong. And where they are spaced out, we can say the magnetic field is weak. Magnetic lines contract longitudinally and widen laterally. Hello everyone. Welcome to session 1 of chapter 5 Magnetism and Matter. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, in the previous chapter, we have studied about how moving charges are contributed for the production of magnetism. So in this chapter, we are going to understand what the magnetism is. So the chapter is Magnetism and Matter. What are the important terms which are related to magnetism and the basic properties of magnetism and many more. We all know that the magnetic property is universal in nature. We have even considered an earth as a giant magnet. We also know that the earth also behaves like a magnet with its geographical north pole and south pole. It also possesses magnetic properties. So let us know about some of the important terms that involved with magnetism. What is the term magnetism called as? Where it is derived from? The term magnetism or the term magnet is derived from a name of a place called Magnesia in Greece. It is believed that people in Magnesia have observed that the small iron fillings are getting attracted towards an ore and they named it as a magnet. What is that attraction property of ore? So the phenomena of attracting magnetic substances like iron, nickel, cobalt, etc. and the body which possesses this property of attraction, this property of magnetism is called as a magnet. Magnetism is nothing but a phenomenon of attraction. So the phenomenon of attraction of particles like iron, nickel, cobalt, and the body which possesses this property will call it as a magnet. As I told you, the word magnet is derived from a name of a place called Magnesia in Greece. A magnetic pole. What do you mean by a term? A magnetic pole. It is a point near the end of the magnet where magnetism is concentrated. Suppose if we consider a bar magnet, the end of the pole, or we can say that the poles of a magnet where the magnetism is concentrated is called as magnetic pole. So these magnets, they contribute a magnetic field around it. So what do you mean by magnetic field? The region around magnet in which it exerts a force on other magnets, or when it exerts force on the other objects, this region will call it as magnetic field. So what creates this magnetic field? It is nothing but the magnet. Now we all came to know what are magnets and what is a magnetic property, what is the magnetism, everything. Let us now know about the types of magnets. We have natural magnets and artificial magnets. So what is natural magnet? Naturally occurring magnet. In nature, we say that a typical black stone we found in nature which has the property of attracting the substances, other substances, and we'll call it as a natural magnet. So basically it is an iron oxide. However, these natural magnets are not strong in nature. They are actually weak in nature, and hence we will develop an artificial magnet for the convenience of our activities. What is an artificial magnet? How can we develop this artificial magnet? So in general, we can prepare or we can manufacture a magnet by passing electric current through the wire wound over magnetic materials such as iron, steel, and etc. So such magnets, what we create with the help of a metal which is wounded with wire, passing an electric current into it, we will call it as an artificial magnet since they are not naturally available in nature. We have studied about the current carrying solenoid in the previous chapter, which is also an example for this magnet. What are the examples for artificial magnets? In general, we get bar magnet, horseshoe magnet, you can observe here, and needle magnet, etc. These are the types of magnets. Let us know some of the common properties of magnets. What are the properties these magnet experiences? We all know that a magnet attracts magnetic substances such as iron, cobalt, steel, etc. Because if we bring these materials like iron, steel or cobalt near the magnet, we can observe the force of attraction between them. A freely suspended bar magnet always aligns in north-south direction. We know what is a bar magnet. It can be in rectangular in shape or spherical in shape. So if we suspend this magnet freely in space, it will align in north-south direction. These poles of the magnets cannot be separated. Suppose if we cut this magnet into two halves, again we will get north-south direction and north-south direction. That will become two magnets with weaker property when compared to the previous magnet. So the two poles of magnet are of equal strength. So these two poles of magnet has equal strength. What is the SI unit of this pole strength of magnet? It is ampere meter, which is denoted by capital A into M. So the distance between these two poles of a magnet is called as magnetic length. Suppose if we have a bar magnet with two poles, north pole and south pole, the distance between these two poles is called as magnetic length. Basically, we all know about this famous or a very familiar property of magnet, that is the like poles of magnets repels each other and the unlike poles attracts each other. An isolated north and south pole does not exist because there is no monopole existing in magnets. It is always dipole in nature. When a piece of substance such as iron, steel or cobalt or nickel, when it is placed near the magnet, it gets magnetized, which means it will also get magnetized. We will call this property as induced magnetism, which is nothing but the magnetism acquired by magnetic substances such as iron, cobalt or nickel. When it is placed near the magnetic field will get induced in that substances and we'll call it as induced magnetism. Now let us know about the magnetic field. Magnetic field is nothing but the region or the space around a magnet or a current carrying wire or conductor within which its influence can be experienced by a small magnet. We can feel the magnetic field or the force of attraction or repulsion around the region. So we will call it as magnetic field. So what is magnetic field line? To illustrate this magnetic field, the lines can be an imaginary lines can be drawn. So magnetic field lines are an imaginary curves that the tangent at any point of these curves can give us the direction of magnetic field. As we have studied about electric field lines in the chapter electric charges and fields, we are studying about the magnetic field lines here. Magnetic field lines are imaginary curves. So if you draw a tangent on any curve which gives the direction of magnetic field at that point. So what are the properties of magnetic field lines? We all are familiar now with the properties of electric field lines. Now we are studying about the properties of magnetic field lines. They are a continuous closed loops. Magnetic field lines are continuous closed loops. As I told you, if you draw a tangent, suppose we have a bar magnet here, there are continuous closed loops. Magnetic field lines are continuous closed loops. It is like this. Suppose if we draw a tangent on a curve, this point gives us the direction of magnetic field at that point. So the large number of field lines crossing per area, the stronger is the magnitude of magnetic field, which means the area where we can see the dense number of lines which is passing through that area, there we can say the magnetic field is stronger. The next property is no two magnetic field can intersect each other, because when two magnetic field intersects each other, we can draw two tangents at that point of intersection, which results in two direction of magnetic field, which is practically not possible. So no two magnetic field can intersect each other. If they intersect each other, the magnetic field direction should be of two directions, which is not possible. Where the magnetic fields are close together, the magnetic field is strong, and where they are spaced out, we can say the magnetic field is weak. Magnetic lines contract longitudinally and widen laterally. They contract longitudinally like this. They get widened when they separate laterally. These are the basic properties of magnetic field lines. Now from this picture, it is very clear to understand the magnetic field lines of a bar magnet. This is a north pole, south pole. A bar magnet we have considered. We can observe two poles at the ends. So it is a dipole. It doesn't have a monopole. The field lines are a closed loop. You can observe here, and it will continue like this. So if you continue like this, you will get a closed loops, and the direction of magnetic field lines you can observe. Suppose if you write a tangent here at this point, this gives the direction of magnetic field. So magnetic fields are crossing from north pole to south pole. So this is the pictorial representation of the magnetic field lines of a bar magnet. So let us now learn about the more properties of bar magnet. What are the characteristics of bar magnet? The bar magnet is most commonly used form of artificial magnet. It can be a rectangular in shape or cylindrical in shape. The bar magnet can also be used as a solenoid. So let us learn more things about bar magnet. The line joining the poles of the magnet is called as magnetic axis. Suppose if these two are the poles, north pole and south pole, the line joining these 2 points, we will call it as magnetic axis. The distance between poles of the magnet is called as magnetic length. You can see this, the magnetic length, which means the distance between north pole and south pole. The distance between the ends. So this is one end, this is the other end. The distance between the ends of the magnet is called as geographic length. So the ratio of this magnetic length and the geographical length of a bar magnet is about 0.84. So what is the magnetic dipole and dipole moment in case of magnets? A pair of magnetic poles of equal and opposite strengths, they are separated by a distance, is called as magnetic dipole. Because we already have an idea about electric dipole, two equal and opposite charges separated by certain distance, we'll call it as electrical dipole. Similarly here, it's a pair of magnetic poles of equal and opposite strengths, they are separated by certain distance, we'll call it as magnetic dipole. What is a dipole moment? It is the product of a pole strength and the separation between two poles. The product of pole strength and the separation between two poles, we'll call it as magnetic dipole moment. So we can compare the properties of electric charges, and here you are studying about the magnetic field and its strength. By comparing these two concepts, we'll call it as electrostatic analog. So the next important topic in magnetism is Gauss law in magnetism. I told you, we are studying the properties of magnetism in this chapter. We have also studied about the Gauss law in electrostatics. So what is Gauss law in magnetism? Let us now learn the statement. So Gauss law in magnetism states that the net magnetic flux over a closed surface is always zero. What is the meaning of magnetic flux? Magnetic flux is nothing but number of magnetic field lines passing through the area. So the net magnetic flux in a closed surface is always zero, is the statement of Gauss theorem. If the surface is divided into many surface elements like small surface elements such as delta S, then the flux, since it is magnetic flux, we are denoting this with phi b, which is equal to summation of magnetic field lines passing through a small area element. So if you sum all the magnetic field lines passing through each and every small area elements, we will get the net magnetic flux, which is equal to zero according to Gauss law. This summation can also be represented by an integral symbol. So that can be phi b is equal to integral of b cross ds, which is equal to 0. In other words, we can also state this Gauss law in magnetism as number of field lines that enter the surface are equal to number of field lines leaving the surface, and hence the net flux or the net magnetic field lines entering into it is equal to the net magnetic field lines leaving the surface. The result will be 0. Gauss law in magnetism is not constant everywhere. It varies from place to place on the surface. Its surface value being of order 10 power minus 5 Tesla, because we know that the SI unit of magnetic field is Tesla. So in this session, we have learnt about few of the basic concepts regarding magnetism and the properties of bar magnet and what are the types of magnets and many more. See you all in the next session. Keep learning, all of you. Thank you.